Welcome back, our valued participants. We're about to start our second technical session. The first session proved to be very, very productive, and I'm sure the next two presentations are going to be as equally good. Let's now move on to the first of the presentations, and I have the pleasure of inviting this dynamic resource person who's going to be giving us a presentation on changing human resource landscape in the digital age. Ladies and gentlemen, he is an associate professor in artificial intelligence at the University of Liverpool, United Kingdom. He obtained his PhD in computer science from the University of Tokyo, Japan in 2009. His research interests have spanned a wide range of topics in artificial intelligence, such as natural language processing, data mining, machine learning, and social media analysis. He's authored over 100 scientific papers in peer-reviewed journals and conferences in these fields, and he's an expert member of the Royal Society Committee advising the British Parliament on the future of work, and is a senior fellow and advisor for various companies that use artificial intelligence technologies in their business. And he's a recipient of many prestigious awards. Ladies and gentlemen, it's my pleasure in inviting Associate Professor in Artificial Intelligence from the University of Liverpool, United Kingdom, Dr. Danushka Bollegala. Everybody put your hands together for a round of applause.
Good morning, ladies and gentlemen. I'm Danushka Bollegala from the University of Liverpool, and I'm going to talk about the changing human resource landscape in the digital age. So I'll do the disclaimer first. So I'm not an HR person, so I'm a computer scientist, and so I would like to thank the organizers of this esteemed conference for inviting a computer geek like me to an HR conference. So I'll try to justify my presence by the end of this talk. So this is my oversimplified interpretation of human resource management. So you have the bosses. I mean, it doesn't look that happy, right? And then there are workers who are doing the actual work, and then there are the human resource managers. So one thing that is happening in this process is that there are a lot of communication going on. So yesterday in Honorable President's speech, so he mentioned that there are writers, mailers, and texters. So one thing that is common there is communication. So the medium of communication has changed, but the necessity to do communication has not changed. So you can't communicate without languages. So if you are going to digitize this field, then it's important for computers to understand language. So that's where I come in. Sorry. So can computers understand language? So surely they can. I mean, there are these things called computer or programming languages, and there are a lot of these things. C, C++, Python, Java, I mean, you name it, a lot of languages. And however, we are more interested in computers to understand languages that we humans speak. Sinhalese, English, Japanese, Chinese, and so on. So these languages are called natural languages, as opposed to the programming languages, where normally you would write a program that a computer could understand. And the field of artificial intelligence, the subfield of artificial intelligence, that focuses specifically on this problem of how to teach computers to understand, at least to look like they're understanding language, is called natural language processing, or NLP. So perhaps in the HR field, NLP is more of an acronym for neuro-linguistic programming, and that's not the NLP that we are going to talk today, right? So we want computers to understand language. But are there applications that are of NLP that is actually used by a lot of people? Surely there are, right? So if you have ever searched on Google using some keywords to try to find some information, you are using an NLP tool, a system. So the search engine needs to understand your keywords And from those keywords, it needs to understand your information intent, and then it must mesh that intent against billions of documents out there on the web and provide the most relevant, maybe 10 or 20 results to you. And all this thing has to be happening in less than a second. So that's a real-world NLP engine. And there are lots of applications of NLP besides search. For example, chatbots. You might say that I don't type anymore. I just talk to my smartphone, and it finds things for me. So you might be using things like Siri or Google speakers, asking it to play your music, favorite music, or searching products on Amazon using Amazon Echo and so on. So these are all still natural language processing systems. These systems must understand the languages that are spoken by humans, right? And another good example of NLP is what is called sentiment analysis. So if you have bought anything on eBay or Amazon or any other kind of e-commerce site, before you do the actual purchase, you would quickly go and look what's been said by other people who bought this particular product before you did. And you want to find out whether there are any particular errors or defects identified by other people, and what is the general sentiment? How do people who bought this product think about it? So, for example, if you are looking at reviews about books, you would think like, for example, words such as excellent, broad, high quality, thrilling to be positive indicators of sentiment, whereas about knives or kitchen appliances, something like lightweight, sharp, excellent could indicate that. So different words are used to express the same sentiment about different things. And if you need your computer to read all the reviews on Amazon and recommend you the best ones, then your computer needs to understand these things, right? So there are lots of applications in NLP in HR as well. For example, in the case of recruitment, you might advertise and get, say, thousands of CVs, and you want to, you might not have time to go through all of those CVs, and you need a system to quickly go through these CVs, check the qualifications, maybe evaluate the sentiment or the excellence of a particular statement written by a candidate, and recommend the best ones to you. And if you are an HR manager in recruiting, maybe before you hire a particular person, you would go through social media and check whether this person is culturally fit for your company. What is this person saying or not? So before you tweet next time, be careful not to say things badly about your next company that you're going to work about, right? So if you want to motivate people, then you need to understand what is their emotion state. So we had an excellent talk from Hitachi, what they do about happiness, and that's a good example of analyzing emotion, right? And then you might want to do appraisals, feedbacks, and so on. So we had a example given yesterday from Google at the keynote speech given by our chief guest from HSBC, where they analyze feedback and provide feedback in real time. So if you are again in HR, maybe there are complaints and grievances that you want to quickly analyze through an NLP system. So there are lots of applications that is already happening in the HR landscape that uses natural language processing. So we want to talk about how to teach computers language. And the first thing we need to find out is whether words have any meaning, right? So if the words don't have any meaning, then there is no natural language processing. And actually, a linguist called John Rupert Firth, way back in 1950s, said that words don't have any meaning. They just borrow from other words. So this is called distributional hypothesis. And Rupert Firth put it in very succinctly in this way: you shall know a word by the company it keeps. Maybe you are applying distributional hypothesis unknowingly in your day-to-day lives as well. Maybe you don't know a particular person, but you know the friends or the person that particular person is associating. So you might guess this person might also have these interests because this is the company that this person, he or she is in. So the distributional hypothesis is a quite an effective way of inferring the meanings of words. So let's look at a particular example. So let's do this quiz. So if you are sleeping in the audience, this is the time to wake up. So we are doing a quiz. So X is a device that is easy to carry around. So you can speak using X, watch the internet, and what could X be? And we are giving some candidate answers. Could X be a dog? Could it be an airplane? Could it be an iPhone? Or is it a banana? Right? So we can think, maybe a dog, if it is small enough, you can carry around. You can speak to your dog, but not using it, unless otherwise you want to bark. Right? You can't surely watch internet through your dog, right? So that's out. Airplane, maybe it's difficult to carry around. You can fly it around. You can't speak or watch internet, right? An iPhone, maybe that looks like the correct answer in this case. A banana, maybe you're lonely, you might want to talk to a banana. But we usually don't do that, right? So even without knowing the meaning of a dog, an airplane, iPhone, or banana, we can represent X just by looking at the context. Things like a device, easy to carry around, speak, and watch internet. So these are the clues or the companions, in the words of Firth, that are defining the meaning of X in this case. So that's the distributional hypothesis for you. And there is no human intervention. It's just a sentence, a couple of sentences written by a human that perfectly defines what is X in this context. So how can we put this distributional hypothesis in practice? How can we teach computers the meanings of words using this principle? So let's consider the word apple. And let's assume that I searched in Google and found this sentence, apples are red. And I do a little bit of further search and find two more sentences. Red apples are delicious, and apples are produced in Washington, and so on. And then I'm looking at the context that co-occurs with apple. So the first one is saying it's red. Second one is saying it's red and delicious. Third one is it's produced in Washington. So these are the context that we can use to define apple for a computer. So your computer is seeing apple as something that is red, it's delicious, something has to do with Washington and can be produced. And that's apple for the computer. Right? So you can define apple even using just 3 sentences. So the computer can do this automatically. So now we have a model of apple, but what can we do with that? We could measure that semantic similarity, type of the semantic similarity between, say, apples and oranges. So again, we go to a search engine, find context of oranges, maybe another 3 sentences. Oranges are yellow, oranges are delicious, say 3 sentences, oranges are produced in California. And then again, we are representing orange using the same distributional hypothesis. So orange is something that is yellow, it is delicious, and something to do with California and can be produced. So the computer has already learned what is an apple and what is an orange. So now you can measure the similarity between 2 things, apples and oranges. So you can do that by measuring the overlaps of the 2 distributions, of the 2 distributions. So we have red, delicious, Washington, and produced, 4 features describing apple, and yellow, the 5th feature, delicious is repeating, and California, the 6th feature, produce is repeating. So out of the 6 features, delicious and produce are common in between the 2 representations. So the computer would infer that the similarity between oranges and apples from this example is 2/6, or 1/3, 30% similarity, which is not bad. We have just seen only 6 sentences. And you already know that apples is something similar to oranges. So this is how computers understand language. And the interesting thing is there are lots of text already written by humans out there. A human would not write a sentence randomly by picking words randomly. So the fact that a human wrote a particular sentence is actually giving good clues about the meanings of individual words. So now we have a tool that we can use to represent meanings of individual words. But words are not the only thing, right? There are documents out there with a lot of words. And we need a way to represent the meanings of documents as well. Right? So one way to do that would be you take your dictionary, open the dictionary, assume that there are 100,000 words in it, and we represent each word by a dimension of a higher dimensional space. And a particular point in this space can represent a document that is ever been written by any human. Let's take an example. Right? Let's say in my dictionary there are only 3 words. I, love, and food. I can live with these 3 words, right? Let's assume that we have only these 3 words in the vocabulary. And we have this sentence, I love food. So you can represent this document or this sentence as a point in this 3-dimensional space, right? So 1, 1, 1 point would correspond to that. So if you have this, the phrase, I love or love food, they will be represented by a point in corresponding hyperplanes. Right? So now assume that there are 100,000 words in the dictionary, but it's not a problem. So a computer has no problem visualizing or analyzing a 100,000 dimensional space. It can still represent any document that you have ever written as a point in this space. So all the documents that you have written are now points in this space, and now you can apply lots of mathematical tools such as linear algebra to do various processing. So now we have a way to represent words, we have a way to represent documents. And this is true, by the way, I love food. Right? And now we are interested in how AI can learn. Right? So we have representations, and we are interested in how can AI learn. I mean, there's a lot of hype already, right? AI learns to do self-driving, to do various recommendations, cooking, and so on. But how is it learning happening, right? So AI learn by mistakes, right? Unlike lots of us humans, right? So humans also make mistakes, but they don't learn, right? So that's an interesting story. So if you're aware of the self-driving cars, so Sebastian Thurn, a professor of Stanford and also a researcher in self-driving cars or autonomous cars, was once interviewed. So the interviewer asked a question. Surely they are self-driving cars, but they do mistakes. I mean, they can have a lot of accidents, and that can be quite threatening for humans. So what do you do about these self-driving cars making mistakes? So the Thurn said, true, they do mistakes, but if I go and correct one self-driving car, that model will be instantly copied to all the self-driving cars in the world, and none of the self-driving cars will make the same mistake again. Can you tell that about human drivers? Right? So that's a strong argument, right? So they do mistakes, but learn. So we'll see how you can learn from mistakes, right? So we'll make initial guess about how world behaves, a model about worlds. If I push the door, it will open and so on. And then I'm going to make predictions about things that are going to happen based on my current model. And if I can correctly predict what is going to happen, I don't have to learn. But if I make mistakes, then I have to learn. Again, let's look at another example. Let's say there's an exam next month, and there's a huge textbook that I have to read, right? So I'm too lazy. I don't want to read the textbook. I'm straight away going to do a mock exam, right? Maybe I do the last year's exam paper, and then I get 100 out of 100. So that means I don't have to read this textbook, because I already have the knowledge to answer that exam. So I have nothing to learn. If I make mistakes, then I will learn things that I did wrong so that I won't do it again. So that is the approach that AI is using for learning things. It's a very efficient approach, right? So let's look at this in practice. Let's assume that I want to learn sentiment about sentences. Let's say somebody wrote, I love sushi, and gave it a positive sentiment, and wrote, I hate tomatoes, and give a negative sentiment for this. So we need the AI to learn that I love sushi means positive, and I hate tomatoes means negative. Let's assume that this is the problem. It's a simple problem, right? So we want our computer to learn this. So what we do is, again, we'll go and represent each document, this sentence, as a point in this space. So I appears once, love appearing once, sushi once, hate not appearing, and tomatoes not appearing. And sentence B, the second sentence, can be again represented using as a point in this space. So we have now two representations for the first and the second sentence. And this is my initial model, right? So I have to start from somewhere. So I'll start with a random model, right? So I'll initialize my model randomly. I think I is a positive thing, love is a positive thing, sushi is a negative thing. I mean, I don't know about sushi, hate, and tomatoes is positive. This is a kind of random guess. So now I'm going to make predictions about sentiment using my current model. So this is my learning rule. So I'm going to compute what is called an inner product. I'll quickly show what this is. Shortly, I'll show what inner product is. Between my current model and each of the feature vectors representing, those are the lists, right? Representing the two documents. If the weighted sum, the inner product, is positive, then I'm going to predict this as a positive sentiment thing. If negative, I'm going to predict this as a negative sentiment. So let's try out. So the first sentence, I is appearing once, and my model says I is plus 1, so I'm multiplying 1 into 1. Plus, I have love appearing once, and love is again having a value of 1 in my model, it's 1 into 1. Plus, sushi has a value of 0, and it appearing in my current sentence, so it's 1 into 0, it's 0. So I'll add up all these weighted sums, and it turns out to be 2, which is a positive number. So my AI is saying that this sentence is positive. I mean, it's a guess, but it is true. So it's not going to learn, right? So I'll try this for B as well. And if you try this to B, then again the score becomes positive. And the AI is going to say that this is also positive, which is wrong. Now the AI has to learn, right? So it needs to learn that B is negative, although A was positive and correctly predicted. So I'm going to present the perceptron algorithm, the first algorithm in this conference, which was proposed in 1960s. It's not a new thing, but it's at the heart of deep learning. So it's kind of a mother of all learning type of algorithm, perceptron. And this is how it works. So if you make a mistake, you'll update your model. So you will use the current model, and you will add to the current model, multiplied your mistake by the label. So that means like you are incorporating the mistakes that you're making in your existing model. So in our case, the next model vector, W1, will be the previous vector plus B into minus 1 because B was a negative example. So I will do my update. So W0 was this, B was this. I'll multiply B by minus 1 and add up to W0. And then I get my next model, which is this. And now I have learned, for example, hate is a negative thing. And if I use my new model to make the prediction, right, now I'm predicting B with a negative score, which is correct. So now the AI has got this correct. Now it's predicting second sentence, I hate tomatoes, as a negative thing, which is right. And it's not, and in this case, it's not, undoing, it's learning. And A is still predicted as a positive thing. So now it learned to predict A as positive and B as negative. So that is AI learning for you, right? It's very simple, right? So, so let's get back to our human resource, digital landscape changing topic. And what is this kind of, what is the impact of these learning algorithms for HI? So throughout the history of mankind, we have always devised various tools to make our lives easier. So instead of rickshaws, we get on cars now. Maybe they'll be replaced by self-driving cars in the way. But the need to commute has not changed, right? So instead of going to libraries to find things, we go to Google. Instead of using Sorbonne for doing computation, we use computers. So we still have these basic needs to find information, to do computation, to travel, to talk, and so on. So just the tools have been changed. And this is not a new thing. So if you think about the Stone Ages, we were still developing tools to do maybe hunting more efficiently. right? So the change is not something that is happening over the last 10 years or so. It's been happening for the last 100,000 years since we turned out to be Homo sapiens, right? So will this AI, remove you from your job? Will you lose your job because of AI? Is that you on that treadmill that's picked up by the AI? Right? So this is a kind of a question that I get asked quite a lot. Sorry about the pointer. So some people say it's years, and there's this very famous research done by Fay and Osborne, which is published by the Oxford Martin program, and which says 47% of US jobs will be replaced by AI within the next 10 years. That's a big percentage, right? And there's a nice graph here. So the x-axis is the probability of getting replaced by AI, and the y-axis is the number of people. And if you can read these very small letters, I'll read it out for you. So the things that are going to get replaced immediately are transportation and material moving, right? So transportation is going to get changed. A lot of drivers are going to lose their jobs because of self-driving cars. That's happening. Production lines, a lot of production lines replaced by robots. And installation, maintenance. Do you remember the last time you installed an update for your browser and so on? Things are happening automatically. And farming, office administration, various type of services. And healthcare, it's recently secured position. You can see green at the very bottom. So doctors and nurses, they're not going to get replaced immediately. The lucky 53%. And computer science, engineering, and stuff. That's me. That's there. So I'm not going to lose my job in next 10 years. It'll be a problem. I have to feed 2 kids if I lose my job in next 10 years. And then you're on the top: management, business, and financial. Right? At least within the next 10 years, you won't lose your job. Right? So that's all this research is telling. But 47% is going to lose jobs, right? Sorry. And there's this nice book, a prediction made by Ray Kurzweil. And you might not know Ray Kurzweil, but we might be using, for example, Google's auto prediction tools for responses in Gmail and so on, which is a team managed by Ray Kurzweil. And it's a nice graph showing, again, it's difficult to see this. It's a log-log plot starting from the beginning of life to the modern computer. So it's a very linear progression. The rate of innovation remains same. So every year, for example, things like Moore's was suggesting that the speed of computers will get doubled and so on. Right? So everything is increasing exponentially. And if you go like this, increasing exponentially, by 2045, remember this year, by 2045, AI is going to get more intelligent than humans. So that is not my prediction, it's Ray Kurzweil's prediction. And this point is called singularity. So singularity has a definition in mathematics. It's a point where the function is kind of undefined or goes to infinities. But this is called the technological singularity. And if AI is getting intelligent with the same rate, so it's going to overpass the human intelligence in 2045, right? So Elon Musk, the CEO of SpaceX and Tesla, predicts that this is going to happen not in 2045, but within the next 10 years. So that's even closer than that, right? So now it's 2018 and 2028, right? And Stephen Hawking, who's no longer with us, unfortunately, predicted that AI is going to replace the humans altogether, not just the jobs, right? But he died, right? So don't have to worry about it now. So there are various predictions made. But what is the implication of this to HR? What does it mean to manage human resource when the humans are replaced by robots? Do you have to change the name of your field? Should you say like robot resource management? Right? So, Bill, as long as humans are working, you will need HR personnel, right? And will singularity really happen? I don't know, right? So some people say, it won't happen. For example, Pedro Domingos is again an NLP researcher who wrote the book about master algorithm, which tries to propose one algorithm combining 6 different fields in machine learning. Says that singularity will not happen if this master algorithm is not invented. And there will be a period where humans and AI will coexist. I mean, think about autopilot, for example. So it's inoperational, right? But still we have pilots on planes. So autopilot has made air travel safer, and it has made possible these giant jumbo jets to be operated by tiny humans. It has enabled humans, right? It has increased the productivity, but they're not replaced yet. So we will have a period where humans and AIs will coexist. And maybe an AI will decide that you should be fired, but you need a human resource manager to deliver you that bad news. You don't want to hear it from a robot, right? So you will still need HR personnel, right? So that's nice, okay, to tell you that you're fired, right? So what can you do in these problems? Surely you have to retrain. You have to have new tools. You have to retool yourself. You have to retrain your workforce. Those drivers who are going to lose their jobs has to learn something new in order to have a living. So there are lots of courses provided by massive online courses, MOOCs, provided by Coursera, Udemy, and for example, to learn languages, we have things like Duolingo. So AI will help you to acquire new skills. AI will analyze what you've learned at the moment and I'll recommend what courses that you have to take next, and so on. So that's nice. And HR managers will have to manage the frustration between AI and humans. So now in your workforce, in your company, there are more intelligent co-workers than you, right? They will do things more intelligently. So, but you have to still, coexist with these robots, AIs. So there will be, jealous humans who will go and unplug the computer or the robot. So you have to manage that. There's another story, nice story. I'll share that with you as well. So there's this big giant company, built a huge AI data, AI kind of a cluster with thousands of computers, and put one dog and a man in this huge, computer kind of data center. So the purpose of the dog is to prevent humans from doing harm to the computers. And can you guess what is the purpose of the man? Feeding the dog, right? So that's what's going to be happening, right? So can algorithms discriminate? You're going to decide who you're going to hire based on AI. Surely it can. It has happened. Algorithms can discriminate. For example, this redlining effect. So this was cases where whether you should be allowed a mortgage or a credit card was decided purely based on data. And the algorithm learned that if you are from a particular postcoded area, you are not allowed a mortgage. And the worst situation is that if people in these areas, underprivileged people, are not allowed loans, then you won't have any data about their loan repayment. So this is a kind of vicious spiral, right? So this has happened. And this was last year, where Google Images accidentally, annotated images of, say, black people as gorillas. There was a huge, issue in Twitter and so on. So this happened last year, right? So this is still discrimination by algorithms. And there are racist AIs as well, right? So Microsoft released their Twitter bot called Tay, and over a period of just 24 hours, it learned to speak very racistly. Things like Hitler did nothing and so on. So these things happen. So AI learned because humans are racist, but then they are very good learners. It only took 24 hours for them to learn these human biases. So these things do happen. And for HR, there's another concern is, there will be a group of people who will be losing their jobs, and how can you compensate for them? How they are going to pay salaries for those people. And one solution is universal basic income. So despite your conditions, if you are a citizen of a particular country, you will be given a particular income that is sufficient to satisfy your basic needs. So everybody will get a fixed income. And there are certain countries in Europe that are seriously considering implementing UBI. But how is this going to affect HR? I mean, now the salary is no longer a motivation to work hard. I mean, everyone is getting a salary, whether you work or not. I mean, how are you going to sustain motivation, right? And for employers also, there are concerns because things like pension or bonuses needs to take into consideration UBI, right? So the future of AI, so irrespective of singularity happens in 2045 or not, so the change is going to take place. So as Lord Buddha put it in very succinctly in 2,000 years ago, the only thing that is certain about change, that is constant, is the change, right? So change is going to happen in whatever form. And do not get intimidated by terms like big data, cognitive computing, cloud, Web 2.0, Industry 4.0, and all that stuff. I mean, just try to find out what they really do. And it turns out they're quite simple enough. Again, you can understand these algorithms using high school maths. And you might ask me, we have said all these arguments, but is singularity really going to happen? Right? So if you invite me to 2045 NHR conference, I'll be able to tell that. So I'll be 66 years old by then, but I'll have the answer by then. So thank you very much for your kind attention. I'd like to take any questions that you might have. Yes, so I'll read out the question again. So there is a concept of learn, unlearning, and relearn. So with this idea, how technology transformed into HR implementation. Yes, so I'll first explain